Hello everyone. In this lecture, we are going to discuss how to find expectation, variance and standard deviation. And also we are going to discuss some important points of expectation and variance. And after that, we are solve some example based on this concept. So let's start with the first definition, that is what is expectation. See here, expectation, that is nothing but the mean value of probability distribution of a random variable x, and it is denoted by E of x. We know that our x is a random variable, that means it may be continuous or discontinuous. So here expectation we define as expectation of x, that is E of x, equals to summation x f of x. Here we are taking summation over x, and this definition we are use when our random variable x is discrete. For discrete random variable, we have to use this definition. Now, for continuous random variable, if our random variable is continuous, then it is not possible to find summation. So we have to use, instead of summation, integral, and for all we have to take integral from minus infinity to infinity x f of x dx. So this is the definition of expectation of x for continuous random variable, and expectation is a mean of probability distribution, so it is denoted by mu also. Now next we discuss variance. Variance of distribution is denoted by sigma square, and it is defined as expectation of x minus mu whole square. The summation over x minus mu square into f of x. This is a for discrete random variable. And for continuous random variable, this sigma square is equals to integration minus infinity to infinity x minus mu whole square f of x into dx. This is for continuous random variable. Now here sigma square is a variance, and if we take positive square root of this term, then that is nothing but standard deviation. So the third term is standard deviation is denoted by sigma, and it is a positive square root of variance. The variance we also write VAR of x. The positive square root of variance is a sigma, and that is nothing but standard deviation. Now we one by one discuss some important points about expectation, variance and standard deviation with the help of some examples. Suppose we want to find expectation of some constant. So by definition, if our random variable is discrete, then it is summation c into f of x over x. Now see here, c is our constant. If we take c outside, then it is summation of f of x over the x. That means for all random values, we have to take probability and their summation. So ultimately it is nothing but total probability, and we know that total probability is always 1. That means here this term is 1, so therefore expectation of constant is equals to constant. So in expectation, if we want to find expectation of any constant, then we get constant. Now next important is, if we have given c into x and we are applying definition of expectation here, again consider our x is discrete random variable, then it is summation c into x f of x. Here c we can take outside because summation is over x, that means c constant we can take outside. The remaining is summation x f of x, here again summation over x, and this is nothing but expectation of x. So we can write it as a c expectation of x. Now see here, if we are taking expectation of c into x, then we get c expectation of x. And if we solve this same example using continuous random variable, then instead of summation we have to use integral. Now see here, if we use the integration instead of summation, then what will happen? Here expectation of c is nothing but integration minus infinity to infinity c f of x dx. Again c is constant, we can take outside integral, Remaining is minus infinity to infinity f of x dx. Again, this is a total probability and always total probability is 1. That means ultimately we get here C. So expectation of constant is constant for discrete random variable as well as continuous random variable. Same concept if you apply for second example, then here expectation of C into x for continuous, it is integral minus infinity to infinity Cx f of x dx. Now see here, C is again constant, we can take outside integral minus infinity to infinity x f of x dx. Again it is nothing but definition of expectation of x. That means C expectation of C into x is equals to C f expectation of x. Hence both answer in discrete as well as continuous are similar for this term, and from this term we can claim that expectation is our linear operator. That means in expectation we can take constant outside, and also if there is a term in the form of addition, then we can separate the expectation, because expectation is ultimate summation or integration, so we can take summation or integral term wise separate. So by using this term we can say expectation is our linear operator. That is, with the help of this linearity property, if we want to solve the expectation of ax plus b, here x is our random variable and a and b are constant. So linearity property separate the term and take constant outside. It is a expectation of x. Now we discuss about the variance. As you know, variance is denoted by sigma square. It is nothing but expectation of x minus mu bracket square. Now see here, x minus mu bracket square. If we apply a minus b bracket square formula, then this term will be expectation of x square minus twice x minus mu plus mu square. Now as you know that expectation is linear operator, so we can separate term wise, and expectation is specially applied on variable x. So here it is first term is expectation of x square, and from this term we have to take constant outside. Mu is expectation of x, that means it is again constant, and here 2 is constant, so 2 mu is constant outside. Remaining is expectation of x plus last term is not contain variable x, that means this whole term is constant mu square. So therefore it is expectation of x square minus twice mu, and expectation of x is nothing but mu, so it is mu square plus mu square. So final formula for variance of x, that is a sigma square is equals to expectation of x square minus mu square. If we write a value of mu in the form of expectation, then it is expectation of x square minus expectation of x whole square. In this way we can find the formula of variance of x. So this formula is very important, because every time if you use this definition, then it will be very difficult for term wise take the summation and solve. But in this term, if we know the value of expectation of x and expectation of x square, then using this term we can easily find variance of x. To solve the variance for any constant, then see here, instead of x if we write c, then it is expectation of c square minus expectation of c whole square. And we know that expectation, if we take on any constant term, then it is constant, so it is c square minus expectation of c is again c whole square. That means we get 0. The variance of any constant is nothing but 0. See, these are some important result. Here variance of x is equals to expectation of x square minus expectation of x whole square. Just हमने अभी ये formula derive किया था. Second, if you want to find variance of x plus y or x minus y, then it is a variance of x plus minus variance of y. That means we can separate the variance. And second is variance of c into x is equals to c square variance of x. Now next we discuss some important examples based on this term. Here the example is, let x be a random variable giving the number of heads in the 3 toss of fair coins, and we want to find expectation of x, variance of x, and sigma, that is a standard deviation. Now see here, tossing of 3 coins. We know that tossing of 3 coins, if we are talking about number of outcomes contained in sample space S, that is n of S is equals to 2 raised to power 3. That means it is 8. Here the coin sides are 2 and number of times we are tossing is 3. That means 2 raised to power 3 is 8. Same formula you can apply for any terms. Suppose we are tossing coin 4 times. The formula is 2 raised to power 4. So using this term we get number of outcomes contained in a sample space S. So therefore tossing of 3 coins we get 8 outcomes in a sample space S. So here x is our random variable denoting number of heads and f of x is corresponding probability. In tossing of 3 coins you may get 0 heads. ऐसे हो सकता है कि we get t. 3 coins के टॉस में तीनों इस पे अपर स्पेस पे टेल हेड या फिर टेल हेड ये इस तरह की पॉसिबिलिटी हो सकती है. तो सपोज वी आर टेकिंग 0 heads, दैट मीन्स वी गेट टी. नेक्स्ट इट मे बी पॉसिबल वी गेट 1 head और 2 head और 3 head. अब इसके करस्पॉन्डिंग प्रोबेबिलिटी अगर चेक करते हैं तो ये प्रोबेबिलिटी दैट इज ए f of x is a probability for x equals to x. तो x equals to 0, that means when we get 0 heads. तो 8 ऑब्जर्वेशन में अगर चेक करोगे तो सिर्फ एक ऐसी वे है जहाँ पे आपको 0 हेड मिल सकते हैं. दैट मीन्स यहाँ पे क्या होगा, टी एक ही है और कितने में से 8 में से. तो हियर प्रोबेबिलिटी फॉर x equals to 0 is 1/8. नाउ फॉर सेकेंड, when x equals to 1, that means 1 head. तो 1 head आने के वेज क्या हो सकते हैं, ये t head t या फिर रहेगा h t और t h. इसके सिवा 1 head आने के कोई वे नहीं है. that means there are 3 ways out of 8. तो probability is 3/8. Equals to 2, probability is 3/8. Same 3 heads, the number of 3 heads probability is 1/8. Now next we have to find expectation of x. So here expectation of x is equals to, our random variable is discrete, so the definition is summation x into f of x. So now here first value of x is 0 and corresponding probability is 1/8, then plus second value of variable is 1 and corresponding probability is 3/8, plus third value is 2 and corresponding probability is 3/8. Next is x equals to 3 and corresponding probability is 1/8. If you simplify this term then it is 3/2. That means expectation of x is equals to mean of probability distribution function of random variable x is 3/2. Now next is we want to find variance of x. So here we know that variance of x is nothing but expectation of x square minus expectation of x whole square. So here we know the value of expectation of x. Just we have to find expectation of x square. So for expectation of x square, it is a summation x square into f of x. See here, if we put 1 by 1 values of random variable, then it is first value is 0 and corresponding probability is 1/8. Second is 1 and corresponding probability is 3/8. When x is 2 and corresponding probability is 3/8 and next random variable value is 3, so it is 3 square, corresponding probability is 1/8. Again simplify this term, so then we get value of expectation of x square is, it is 3. So therefore if we put this value in our formula, then variance of x is equals to expectation of x square, that is 3, minus expectation of x whole square, so it is 9 by 4. Simplify this term, it is 12 minus 9 divided by 4. So 12 minus 9 divided by 4, so it is 3 by 4. And third, we want to find standard deviation. So standard deviation is sigma. It is nothing but positive square root of variance of x, and from this term it is under root of 3 by 4, that is nothing but under root of 3 by 2. Similarly, we discuss one example for continuous random variable. Example is, let x be a random variable with density function f of x equals to 3x square when 0 less than equals to x less than equals to 1 and it is 0 otherwise, and find the value of expectation of x and variance of x. Now see here, given is density function, that means our random variable x is continuous, and for continuous random variable we want to find expectation of x. So the definition of expectation of x is integral minus infinity to infinity x into our function f of x dx. See here, x is random variable, that means value of random variable is lies between open interval minus infinity comma infinity, and see here, this value corresponding to this value of function is different. That means when our x is lies between 0 to 1, then value of function is 3x square, and for other term it is 0. In the next step, if we break this integral, then this integral is minus infinity to 0, see here, minus infinity to 0 x f of x dx, then plus second is 0 to 1, so it is 0 to 1 x f of x dx, plus next is 1 to infinity, so it is 1 to infinity x f of x dx. And here the value of function is 0, and in last term value of function is 0. That means if we put value of function 0, then whole integral is 0. So no need to write 0, that means first and last term is 0. Just here we have to put value of function. So therefore it is integral 0 to 1 x, and in 0 to 1 function is 3x square dx. This integral is very simple. You just take constant outside, and integration of x cube is x raised to the power 4 by 4, limit is 0 to 1. Now here put upper limit minus of lower limit, so then we get value of expectation of x, that is 3 by 4. In this way we can find expectation for continuous random variable. Now next task is, we want to find variance of x, and again here variance of x is nothing but expectation of x square minus expectation of x whole square, and here we know the value of expectation of x, so just we have to find expectation of x square. To find expectation of x square, again I use the definition, it is nothing but integral minus infinity to infinity x square into function dx. But we know that for minus infinity to infinity function value is different, and it is 0 for minus infinity to 0 and 1 to infinity. So just value is exist in 0 to 1. So if we break this term, then it is nothing but integral 0 to 1 x square, and in this integral value of function is 3x square dx. Now again here constant we can take outside. Integration of x raised to the power 4 is x raised to the power 5 by 5. If we put upper limit minus of lower limit, then it is 3 by 5 with this value for expectation of x square. Now if we put this value in our formula, then variance of x is equals to expectation of x square, that is 3 by 5, minus expectation of x whole square, that is 3 by 4 whole square. So 3 by 4 whole square is 9 by 16. Simplify this term. If we cross multiply and then simplify, then we get 3 by 18. So hence variance of x equals to 3 by 18. In next term, if we take under root of this term, that is nothing but value of standard deviation.
Thank you. Like, share and subscribe.